Good day, ladies and gentlemen. My name is Chris Clark, Managing Director of Rocketmine, based in Johannesburg, South Africa, and I'm joined by my colleague Devin Hassenbroek. We're very honoured and privileged for your time this afternoon to give you a presentation on how we've been able to take digital twins and integrate with augmented reality technology to come up with a really cool and I guess really practical application of using these two technologies in a real-world example. We really a lot of the focus has been on about what is an actual digital twin, and really where has it been implemented across the world. And I guess if we really start off with the baseline example of a digital twin, it's really a lot more than just a 3D model. Ideally, it's like what you're seeing on the screen here. It's a realistic representation of your physical assets that currently exist, but really adding on information layers and making those physical assets a lot more, let's say, useful. Making those physical assets a lot more informative, not just what you see in front of your own eyes, but what information layers can be overlaid right in front of you, kind of like Iron Man style. So, if you look at again the baseline of what really a digital twin is, it's about in the middle looking there, saying taking an asset, building the 3D model, but pulling in information that already exists in the engineering, operational, and information age. So even your basics, what is about looking at the PDFs that you already have existing from engineering drawings, from any kind of analysis, and combining that static information with what we refer to as that operational or dynamic information, such as IoT sensors, any kind of live feeds that are pulling through, and then giving them a tag, tagging them to each and every individual asset. And a digital twin can be as big as a big plant, as well as go down to a very small asset such as a pump. And how you make that useful can be then exported into many different types of other platforms. And today we're going to be showing you our augmented reality application, as you will, of how we will take some of the static and live information, overlay it on top of our 3D model of a live working plant, and how it can be applied in real time for a person who's wearing today, and what we'll be showing you is a Microsoft HoloLens device in an augmented reality space. Again, a lot of people, when they kind of think of digital twins, and this is kind of our disclaimer, a lot of people and rightly believe that digital twins is really about kind of this level 5 of building predictive and analytical scenarios and planning for digital twins. But to be honest, and we'll be the first to tell you in our experience, is that really customers and projects are really only at the beginning levels at the moment, where it's really about capturing, tagging the information, and then slowly linking the data. There are some very exciting projects out there, and different products, but very few people have been able to really kind of pull this all together to get to the true level 5 scenario. So today we'll be getting up to this level 3 of what you see on screen, which is to show you the progress of how we've gone about capturing an information and telling you the story about what we've done in doing a simple asset tagging of some assets on a brownfield plant, and then pulling through the live information on an augmented reality device. So how we as Rocketmine got into this journey of taking digital twins and augmented reality and combining them together is that we are predominantly, or started off as a drone data acquisition company based in Johannesburg with branches in Ghana, West Africa. And we had one of our gold mining customers in West Africa give us a call and say, look, I'm really, really struggling to be able to get my expats onto site. The local governments won't give expat visas, but we need to get our engineers in Canada and UK to be able to get access to the sites in this case, Ivory Coast. And that really kind of sort of piqued our interest. Already we had guys on site flying drones, creating 3D models and orthomosaics, but now we needed to be able to extend that reach to allow this live information and for engineers in the UK and Canada to be able to assist those on site when you know what I mean, to allow for that kind of help. And this is really the concept that we came up with, and we started going on a work of building a proof of concept around digital twins and augmented reality. So what we then did is we went ahead and using a software platform called Bentley PlantSight, is that we used our experience in the drone industry to create this 3D model and essentially build this digital twin on the Bentley platform as well. The really great thing about the PlantSight, what we found is that it really allowed and had the APIs and the SDKs available for us to again not only put the model on, but to also be able to pull through and simulate data as well. So to give you a quick example, so we took a drone, and using photogrammetry, we're able to model this processing plant on one of our customer sites. It's a platinum mine. You can see the sort of the level of the detail that you can get, and you can drill down. So you can really start off quite large. So what will happen is that we would go out, use a drone, do some photogrammetry modeling, build these 3D models, and then upload this into the PlantSight system as well. Then the idea is that once you've created the actual model itself, you could then go and start doing all the asset tagging. So in this particular case, you can start really sort of taking your assets and really start pulling through the information in each of these assets as well, and linking the critical information. So the idea really is that to make a digital twin useful, you're going to start overlaying the first bits of information and pulling through the dynamic or the operational info, and then start setting your alarm systems and sort of boundaries. And as you can see here, you can really draw around a particular asset. We've sort of set an example here of a particular asset and sort of triggering off the events. And the idea is that once in a web version and sort of this 2D, let's say, a setting, once you've seen this in sort of 3D and you get this alarm, the idea is that you then want to be able to dispatch a technician or an engineer to the actual assets, who's then going to be able to fix it. And we want to be able to not only again give the expat who's sitting overseas not only just the 3D model, which can be updated on a daily or weekly or monthly basis, but you also want to be able to give them the context of now what's happening on ground. Now that there actually has been an alarm that's gone off, a trigger has happened, what do we do now? So we take it one step further, and this is where now the Microsoft HoloLens device and augmented reality now comes into play. The whole perspective was to go out, capture the whole entire area, tag particular assets, attach them to alarms or IoT or monitoring systems, and we would then you could then monitor them, right, from a control room. What we like to call kind of a shared engineering service, so very similar to how finance and IT and all the services have these sort of shared service desks. You can have that with engineering. And once you'd have an asset that would trigger off an alarm, you would then dispatch a technician or engineer who would then have to go and perform a routine procedure, right, on a particular asset. And this is now how we now integrate the artificial reality.
Yeah. So basically, this is what you're seeing now is exactly what I'm seeing through the HoloLens. So I do have the device on, and I've got this little drone in front of me here. So what we did in lockdown period was that we modeled this drone. So what it means is that, well, the theory or the thinking behind it is that whenever you have a task on site that there aren't, sort of engineers or anyone that's trained to do the maintenance or upkeep of a certain piece of equipment on site, you can build these sort of animations on how to get this project done. So what we've done is it's just a little how-to video on this drone, how to put it together. It's a few simple steps, but obviously this can be extrapolated to any engineering piece of equipment. So I'm going to go ahead and get started. Yep.
Sorry, do you just take a step back? Sorry, so we can just see everything. And just the drone. So yeah, perfect.
Okay. All right, so you can see here in front of me, I've got all the tasks to set this drone up. And what I need to do is just click on the start button over here. I'm going to go ahead and do that. And all I'm going to do now is just follow the animations that we're seeing on screen here. So the first one, it's asking me to put the memory card in the drone. So go ahead and do that. And when I finish the task, I can just go ahead and click next. And it'll just take me through the steps here. Another interesting thing is that the drone is, or the I suppose digital twin here is pulling through the live battery log of this battery that's in the drone, and you can see it's sitting at 3%. So if I can just go ahead and I'm going to that one out. And then just follow the prompts and put the new one in again. Charge battery. So I'm going to go next. You can see now the battery is sitting at 98%. So it's pulling through. Next thing is to just turn the drone upside down. Just need to remove the protective cover. Just click and guess once I finish the task. Another cool thing is if I want to replay the previous step, I can go and click no replay here as well, and it'll take me through that previous step. Let's open up the drone arms over here. So yeah, you can really see it's just nice and easy, and exactly what you're seeing, I'm seeing as well. Open up the pillars. Yeah, it's asking me to turn the remote controller on. Done that. Click next. Drone upside down. Check the battery level. Yeah, turn it on. Okay. The drone back down again. And that's it. Drone setup complete. Go ahead and go fly. I'll just take you for a walk around the office here. Okay, I'll just drop you there.
Great. Perfect. Devin, let's perform as an example. We're gonna sort of we're in COVID, so we're all kind of like locked in our buildings. We can't be at the plant right now, but we're gonna, I guess, perform a complex task, right? You kind of followed that procedure using augmented reality. You didn't come right. How can I assist you today?
I really want to turn the aircon off. If you can help me with that, please. And the dial is here right in front of me.
Sure. Just so we're clarifying, we're going to be looking at this. I mean, these two over here. I'm just going to just want you to go just to have a look a little closer at this for me, if you don't mind. Just going a little closer. Yeah. You see the red circle there?
Yeah.
If you just go a little bit lower for me, I can just have a look. Thank you. Yeah. And I'm just going to put a little arrow here on this button there.
Okay.
You can press that, and that's on and off. Yeah. Perfect. I'm going to clear that. This is purely about taking something really, really large, doing the 3D model, but making a digital twin practical today. Because while digital twins are really expected in the near future to be able to offer this level 5 of predictive analysis and sort of self-correcting sort of formulas in the world, we really wanted to say, well, how do we take where the world is practically at a level 3 in a digital twin, but and make it useful on site today, not only for remote engineering services or remote assistance, but also even in a COVID world when necessarily not everyone can get onto site, you can't have too many people on site, and we can collaborate. So Devin, I don't know if you want to just quickly maybe just show off, maybe just going through the XR10 device.
So this is the Trimble XR10. which is essentially a hard hat, a Trimble hard hat, and a Microsoft HoloLens 2 device built into it. This is obviously the augmented reality goggles, or that sits at the front, and at the back you've obviously got the PC or the computer and the battery that sits over here. There's also this device at the back here called a Mobilis, which is essentially these little vibrating pads which sit just behind your eardrum on the sort of the solid part of your I don't know what the right word is, the cranium of your head, I guess, and it vibrates through that, and you know, that's where the audio comes through. So what happens is, as the vibrations come through, you can hear still with hearing protection on as well. So if you have any hearing protection on, you can still hear everything loud and clear. Yeah, you can obviously also lift up the goggles if you want to have a normal view, and you can obviously wear this in any site. It is obviously a hard hat. So that's
there you go.
like.
Great.
Appreciate it. Thank you, guys.
No, thank you. We really appreciate it. Ralph, thanks again for the opportunity.
All right.
Thank you, guys.
Thank
Thanks,
you.
everybody.
Take care.
Cheers, guys.
See you, Ralph.
Bye-bye.
Bye-bye.